This first problem is just an exponential expansion, and what I would see is 13 factors of 3 on top, 7 factors of 3 on bottom. If I expanded it, there would be 7 factors in common that would cancel. The shortcut is that it will be a power of 3, and the power of 3 that it will create would be the top exponent minus the bottom exponent. That's the rule, and that's all I'm going to do is just apply the rule. So 13 minus 7 is 6. Now at this point I could do a couple of different things. I could leave it at that, or I could go ahead and crunch out the numbers and find out what 3 times 3 times 3 times 3 times 3 times 3 might be. And if you just crunch it through a calculator, I think the answer will come out 729. That's a 9 times a 9 is 81. 81 times 9 is 729. There's no clear rule on when you should take a number and crunch it to a value as opposed to leave it as just a number. For instance, if you came up with something like 12 to the 7th power, that's usually left as 12 to the 7th power because it would make such a large number and so messy to write. But there's no clear rule on when the power is supposed to be changed to an actual number. So in essence, either one of these is considered an acceptable response. This is, again, I could write 3 factors of y times 9 factors of z divided by a factor of y and a factor of z. But here's the typical form that I would take. I would ask for the sign, I would ask for the number, and then I would ask for the power. So the sign of the answer is going to be positive. The number is 1, so it doesn't even have to be written since there's only 1 of everything. And the power, I'm going to look first of all at only the part of the problem that involves y's. So y to the 3rd power divided by y to the 1st power is just a 3 minus a 1 is a 2. That's a y squared. You could see that as a y times a y times a y divided by a y, and there's the cancellation, and that leaves the 2 factors of y. However, when it's time to run the shortcut rules, if you don't see an exponent on a number, it is considered to be at the 1st power because there is 1 factor of the y. So by the same token, I would look at only the z's and figure out what the power of z should be. So the power of z is a 9th power of z, 9 factors of z, divided by a 2nd power of z, 2 factors of z. So now I'm only looking at the z's, and that would be simply a z to the 7th. Now the typical rule that you follow on simplifications is that everything has to be written with positive exponents. And so everything is written in positive exponents, and so the final best answer is just the correct power of y times the correct power of z. So y to the 2nd times z to the 7th. So we'll stop with that, and then we'll do 2 more in the next video.